Hello students, now we are going to discuss about the quality control of drugs of natural origin, right? So when we talk about the quality control of drugs from the natural origin, here we need to ensure about the drugs quality, its identity, its purity. Since these drugs are obtained from the natural sources, maybe from plant source, maybe from animal source, maybe from the mineral, microorganism or marine source, right? So ultimately we are going to use these drugs for the therapeutic purpose, for the its activity, for its efficacy, for to cure the disease and disorder, right? So nowadays there is a one malpractice it is going on into the herbal market, like the peoples, they are mixing the drugs to increase the bulk quantity for marketing purpose, and it becomes very difficult to ensure that its quality and purity, right? So there are certain methods we are going to discuss in this topic, which will help us to identify, because this admixture or this mixing or this malpractice it is going on in the such a hi-fi technique or in scientific techniques, it is very difficult to identify the drug or its quality and purity by the simple method. So we will be also having these scientific methods and all other things, right? So coming to the quality control of drugs of natural origin, first we need to understand adulteration, because of this adulteration only we need to have the quality control, this confirmation, right? So what is adulteration? First we have to understand it is a practice of substituting original crude drugs, right? What is it? Is a practice or maybe malpractice, we can say, right? Substituting of the crude drugs partially or maybe whole, completely replacement also we can do, or maybe after some portion or some quantity we are going to mix with other similar looking substances, like which is going to be same, like if it is Rolfia root, so other root which we are mixing, it will look like a Rolfia root only, or maybe cinchona bark, so other barks are also going to be mixed. In oil also we are going to mix, like in honey the some jaggery will be mixing, right? So like that similar looking substances has to be mixed, but these are either free from or maybe inferior in chemical and therapeutic property, right? So we have to understand here it is free from, maybe it will not be having any medicinal value, or maybe low medicinal value or low value which is going to be there, but at the same time it is going to increase the quantity, right? So then only it will be done for the for marketing purpose, right? So for this adulteration we need to know about the evaluation, right? So drug evaluation may be defined as the determination of identity of the crude drug, whether it is senna, if it is leaf, then what kind of, whether it is particular senna leaf only or some other types of leaf has been mixed, or Rolfia root or only Rolfia root, or some purity, what kind of purity, the chemical constant, like in Rolfia reserpine is there or not, in digitalis digitoxin is there or not, like, and the quality, whether that particular chemical moiety is there in that particular drug having the sufficient therapeutic quality or not of a drug, with that we are going to ensuring, right? So when we talk about the method of drug evaluation, the first thing which comes, that is the organoleptic or morphological evaluation, right? So as the name indicate, organoleptic, organ, sense organ, by the sense organ we are going to ensure the quality, purity and identity of the particular crude drug. So in this method of crude drug evaluation, the crude drugs are evaluated by using the sense organs, such as it may be eye, by eye we are ensuring the color, or then nose we are ensuring the odor, the tongue we are ensuring the taste, and shape and size again with the eye, etc. To know the color, odor, taste, shape, size and its texture or outer appearance or morphology. So let's try to understand by the examples. So when we talk about the examples, the first thing, color, maybe each and every drugs are having its own color. For example, brown. So cinnamon bark, whenever we are going to get the cinnamon bark as a sample in the, as a quality control pharmacist, we are going to see that WHO monograph, and it has given the brown color. So original crude drugs, it will be brown color, it will not be pale brown or light brown or something black or dark like that, okay? So then white color. So when we talk about white color, starch will be always white in color, right? So it has been isolated from the starch from the rice, potato, maize, or maybe some other grain, maybe right? So whatever the purified starch, it will be white in color. Pale yellow color it is going to have in ginger. If it is deep yellow, it is licorice. If it is peeled, then it will be deep yellow color. Then deep brown we are having nux vomica. Dark brown, clove right? Clove, that flower buds, it will be having dark brown, reddish brown cinchona, right? So in this way you can you will be able to remember it easily. That's what I have designed in a such a way. The sequences has been made in a such a way so that it will be easy to remember, like yellow in one side, and the this drug you can then brown, 3 brown, pale brown, dark brown, reddish brown, next formica, clove, cinchona. So it will be easy to remember for you in the exam. Odor, when we talk about odor, aromatic umbelliferous fruit like coriander and other things, right? Fennel and all. Pungent ginger, pleasant honey. Then we are having taste, different taste, maybe sweet taste. We talk about the licorice will be having sweet taste, and honey will also have the sweet taste. When we talk about bitter, so all the alkaloidal and glycosidal containing crude drugs will be having bitter in taste. Mucilaginous, when we talk about the there is a linseed and acacia, tragacan, all those are the example. In astringent, all the tannin containing crude drugs like myrobalan fruit and pale catechu, black catechu will be having astringent. Mucilaginous means ipecac, acrid in coca, right? So with these kinds of things we can have the evaluation. And further in this in organoleptic itself, we can have the shape and size also, apart from the color, odor and taste. So when we talk about the shape and size, right, so we are having cinchona bark, right? So in cinchona bark, when we talk about the shape, it will be curved and squill, right? Whereas 30 centimeter length and 2 to 7 millimeter thick, right? So that's what a bark means. It will be curved like this, right? So it will be like that. So you can see the images and other thing, right? Then Raulfia root, cylindrical, right? It will be cylindrical. So this also and tapering, slightly tapering also it will be there. It will be like not proper straight cylindrical. 2 to 10 centimeter length and 5 to 22 millimeter the diameter. Whereas senna leaf, acute apex lanceolate to ovate lanceolate, 3 to 5 centimeter length and 2 centimeter width. Okay. Then we are having ephedra stem. Ephedra stem, it will be cylindrical and woody. It will be woody stem and 30 centimeter length and 1 to 2 millimeter thick. Okay. So this again, it has been one example has been taken from the different types of drug: bark, root, leaf, stem, and first shape and size. So it will also arranged in such a way so that it will be easy to remember for you in the exam, right? Now second method of evaluation, that is the nothing but microscopic, or it is also known as anatomical evaluation. So in this method, the crude drugs are evaluated by using microscope. Compound microscope generally we use in our laboratory. It can be used to identify organized crude drugs. Yes, unorganized crude drugs we cannot do microscopic evaluation. By their known histological characters, by WHO monograph has been given their known histological character, means for example, if it is senna leaf, right? So in senna leaf there will be the trichomes, then vascular bundle, xylem, phloem, stomata, lower epidermis trichomes. If it is bark, there will be the medullary rays, stone cells, right? If it is root, there will be the cortex, cambium, and so many things. Like a special arrangement it is going to have, that we are going to use, right? If it is leaf, we are having stomatal number, vein islet number, vein termination number, palisade ratio, and all those things can be evaluated. So let's try to understand by the example. When we talk about example, stomatal number, for example, what are the stomatal number? Number of stomata per square mm area of the leaf in epidermis, right? So for example, it is also fixed. Atropa belladonna, 7 to 10 stomata number up in upper epidermis and 77 to 115 in lower epidermis. Whereas in Dhatura metal, we are going to get 147 to 160 in upper epidermis and 200 to 209 in lower epidermis. This is fixed. It is going to come in this range. Okay. So this range, if it will come, it will be easy for you to understand or remember. Okay. So in that way it has been designed. So when we talk about this one, again we are having stomatal index. So there is a formula: stomatal index equal to S by E plus S into 100, right? So S is what? Stomatal number, epidermal cell stomatal number into 100. Like for belladonna, it is going to be 20.2 to 23. It is also fixed. If the drug, the given sample of leaf, it is coming the stomatal index within this range, means that is the belladonna only. Otherwise we will ensure that it is adulterated one or it is substituted one. Okay, then vein islet number. So number of vein islet per square mm of the surface of the leaf, right? So that's what in leaf there will be the veins, right? So this is what is the vein islet that we are going to fix in that also 1 square mm area of the leaf. For example, digitalis it is 2.5 to 3, and whereas in eucalyptus it is 8 to 13.5. That also this range has been given by the monograph. Vein termination number, that when the vein termination per square mm area of the leaf surface. So for senna it is 8 to 10. And we also can mention the lycopodium spore method for determination of the quality and purity of the particular drug. Okay, so there is a one formula which will be asked generally. It is there in the practical also. N into W into 94,000 into 100 divided by S into M into P, right? So here lycopodium spore we are going to take. So what is the this N is stand for number of starch grain in 26 field, right? So here we are going to take the lumbus chamber. So in lumbus chamber there will be the different square. This will be useful for the WBC counting also, right? So what is happening here in this lumbus chamber, we are going to make the solution, make the suspension of this particular drug and lycopodium spore and all other things, and we make the suspension. This we are going to put into the lumbus chamber, and that we are going to observe under microscope. What is the number it is coming in per square? So number of starch grain in 26 field. This is going to be a 26 field, right? Weight of lycopodium in milligram. How much weight you are taking, right? How much milligram you are going to take for this suspension. Then a number of lycopodium in 25 field. So how many number of lycopodium it is falling when you are adding this particular suspension into the lumbus chamber. Then weight of sample after drying into the 105 degree centigrade, dried sample, not wet one, right? So that we are going to which drug you are taking, that drug weight you have to write in the M, and the P is 2,86,000 in case of ginger starch if you are taking. So this value is fixed, so that you can put into the in place of P. Then you are going to calculate this and you will get the percentage purity, right? What you are going to get here, percentage purity of the particular drug, how much pure the drug is, right? So by using of the microscope we can determine this also, and we can ensure the drug, given sample of drug is pure one or not. Okay, so further we'll discuss in another video. Thank you all.